Hi, today let's talk about Unikernals. A lot is being discussed in the market and internet that the world of containers has a new competitions, Unikernals, mainly for the cloud-based infrastructure. We all know one of the biggest reasons why containers has grown so big is because of the growth in the cloud technologies around the tech world. But there has been a question if containers or are containers fully providing all that DevOps requires? And if not, then the question is unit runners going to fill the gap? Let's find out. Well, what they are saying is that unit runners realize the DevOps streams. They provide specialized single address space machine images. Note that unit runners consists of mainly three components: system libraries, language runtime, and the necessary applications. And these components are built to form one bootable image that can be directly executed on the hypervisor. The biggest comparison between unikernels is the differentiation between the operator's responsible for managing the applications and the developers who code the application. Unikernels strive to meet the DevOps requirements by making sure that the development team bundles everything into a deployment unit. So deploying unikernels applications require rebuilding the virtual machines again using the configuration tools. But why is everyone thinking that unikernels is going to replace the containers? For 6 reasons. First one, Unikernels, see, they are basically a VM at the code. It supports any clouded or it could provide and it could work on any platform. They're independent, and it is very easy to shuffle between different clouds. Also, it adopts a serverless approach, which means we are avoiding the vendor lock-ins here. And second one, managing and operating containers can be time consuming or maybe a bit complex in some scenarios. Also, too many tools for different container platforms and operating systems containers may require operating teams to assist is mainly in managing and deploying the Kubernetes based application. On the other hand, unikernel, as a matter of fact, it's a core VM at the core, and it's mainly about running some commands up to bring up and running. So we are avoiding the complexity of the containers here. Third one, as we know, cloud technology is a child of virtualization, and uniternals at core are virtualizations. This is very fast to get into the market, or these are very fast to adopt it because virtualization has been in the market for decades. Fourth one, with uniternals, the developer has to combine everything that they need into a deployment unit. To deploy an application, the entire virtual machine gets rebuilt and takes less space and time. It's mainly to ascertain on how much memory the application is using is easy as the developer can rebuild the observability and the configuration logs to appropriate service. So this is a proper way of this makes the whole DevOps part very easy for the developers as well as the operators. Fifth one, and also uh, containers and their applications have many problems or can have problems, which is why they are not be around forever. Maybe they may not be around forever. Containers have the possibility of losing the organization's databases. However, it's unlikely to happen with unikernels since one can pause, stop, restart, and even live migrate databases very easy. So this brings a lot of comfort on when we want to manage the databases and stuff. Also, there is no need to use a third-party software to do so, as many of the above things that we said or the things that we shared are mainly read as a plain virtual machine because unikernels at core is a virtual machine. And there have been complaints that Kubernetes faces serious performance issues and all, but that will totally be that can be avoidable with the unikernels. Obviously, the last thing and the main important thing is the security. See, most remote code execution attacks at the shell level to alter the system or like that's how the hackers work, right? But with the unikernels, we do not have to do any shell coding at all. So that attacker does not have a chance to attack this shell code. Also, usually on the Linux-based systems or system trolls are often used to troll at the operating systems and attack the computer systems. Unikernels don't have the operating system, and therefore there are no system calls. There's no operate, they only operate on the function calls. The hackers will have to understand the exact memory layout of the application to call the operating system. So which is really hard because these basic details, or these are the critical details of the application, is not exposed outside. So it makes really hard for the attacker to use the sync trolls or use the system trolls to attack the unit kernels. So which makes unit kernels much more secure. So these are some of the basic reasons, right? So are they going to immediately, in my opinion, are they going to immediately replace the containers? No, definitely not. In the long run, yes, maybe there is a possibility. I didn't see. We're also seeing that containers are evolving a lot. Like a lot is being worked on to make it life easy and make it life where we can adopt the DevOps process easily. I'm sure containers will be very much more matured by the time unit kernels is fully adopted at the organization. But you know what? In parallel, unit kernels can be evolving and maybe make more our life easy. A change can never happen. So there's a good possibility as well as there's not a possibility. Thank you.